Hello everyone and welcome to the very first lesson of our complete Dart programming course. If you're planning to become a Flutter developer, you're in exactly the right place because before we build beautiful mobile applications with Flutter, we need to master the language behind it. This course is designed for complete beginners, but even if you've programmed before in Java, JavaScript, Python, C Sharp, Kotlin, or Swift, you'll still learn modern Dart features and best practices. By the end of this lesson, you'll understand what variables are, the most common data types in Dart, the difference between var, explicit types, and dynamic, when to use final, when to use cost, what the late keyword does, best practices that professional Flutter developers use every day. So open your favorite code editor, grab a cup of coffee, and let's start learning Dart. Before writing our first line of code, let's quickly understand what Dart actually is. Dart is an open source programming language developed by Google. It was specifically designed to build fast applications for Android, iOS, web, desktop, and embedded devices. One of the biggest reasons Flutter became so successful is because of Dart. Unlike JavaScript, Dart was designed from the ground up with UI development in mind. Some of its biggest strengths include strong static typing, excellent performance, non-safety, object-oriented programming, functional programming features, asynchronous programming, great tooling, hot reload with Flutter. Don't worry if some of these terms sounds complicated. We'll cover everything step by step throughout this series. Let's begin with one of the most fundamental concepts in programming, variable. What is a variable? A variable is simply a container that stores data. Imagine having labeled boxes. One box stores your name, another stores your age, another stores whether you're a developer. In programming, variables work exactly like those labeled boxes. For example, var name is equal to Jacques. Here we created a variable called name. Inside that variable, we stored the text Jacques. Later, we can access it, print name, and we got the output Jacques. Variables allow our programs to remember information. Without variables, programming will be nearly impossible. One important thing about Dart is that it is statically typed. What does that mean? It means every variable has a type. For example, var age is equal to 20. Dart immediately understands that age is an integer. From that point on, age is equal to 25 works perfectly. But this age is equal to 20, like this in string, produces an error because an integer variable cannot suddenly become a string. This is called type safety. Type safety allows Dart to detect mistakes before your application even runs. This leads to fewer bugs, better performance, better autocomplete, easier maintenance. Most of the time, you'll see developers writing var city is equal to London instead of writing string city is equal to London. Why? Because Dart is smart. It automatically detects that London is a string. This feature is called type inference. Even though we wrote var, the variable still has a fixed type. This surprises many beginners. Var does not mean dynamic. It simply means, dear Dart, please figure out the type for me. Once inferred, var city is equal to London is exactly the same as string city is equal to London. Sometimes we prefer writing the types ourselves. For example, string username is equal to John. This is called explicit typing. It makes the code easier to understand, especially when reading large projects. Professional Flutter developers often use explicit types for public APIs, class properties, function parameters, while using var for local variables. Now let's discover Dart's most common data types. Integer. Integers represent whole numbers. For example, int age is equal to 25. Int score is equal to 150. Int population is equal to 90,000. Now decimal point. Double. For decimal numbers, we use double. For example, double price is equal to 19.99 cents, double temperature is equal to 28.5, double height is equal to 1.82. Any number containing decimals should use double. String. Strings store text. For example, string first name is equal to Alice. Strings can use double quotes, for example, hello, or single quotes like hello. Both are perfectly valid. A Boolean stores only two possible values, true or false. For example, bool is logged in is equal to true. Another example, bool as internet is equal to false. Booleans are extremely useful for decision making. Later in this course, when we learn if statement, you'll use Booleans constantly. Applications rarely store only one value. Usually, we need groups of data. This is where collections come in. The first one is list. List store multiple values. For example, a list of the name of the fruits. We will have a list of type string containing apple, orange, and banana. The second one is map. Maps store key value pairs. For example, a map that contains the details of a person. We have the key name and its value Alice, the key country and its value Canada. Instead of indexes, we access values using key, but in the list, remember, we access data using indexes. The third one is sets. Sets also store collections. However, they automatically remove duplicates. For example, a set of numbers containing 1, 2, 3, 3, 2, like this with duplicate, but the result in the output will be a set of 1, 2, 3 without duplicate. Very useful when uniqueness matters. Let's talk about less common types. That also includes runes used for Unicode characters. Symbols rarely used outside advanced programming. You don't need to master these today, just know they exist. Now, let's discuss something beginners often misuse, the dynamic type. For example, dynamic value is equal to hello. Later, value is equal to 10, and later again value is equal to true. Everything works because dynamic disables static type checking. Although this provides flexibility, it also increases the chance of runtime errors. Professional developers avoid using dynamic unless absolutely necessary. Instead, prefer using string, int, double, bool, list, map, or a specific type to make your code safer and easier to maintain. Var versus dynamic. This is probably one of the most confusing topic for beginners. Let's compare them. For example, var name is equal Alice. Later, name is equal to Bob works, but name is equal to 30, this will pop up an error. Now compare with dynamic. Dynamic name Alice. Later on, name is equal to 30, perfectly valid. Var means that chooses the type. Dynamic means there is no fixed type. Huge difference. What about constants? Sometimes value should never change. That provide two keywords, final and const. Although they look similar, they are not the same. A final variable can only be assigned once. For example, final username is equal to fetch username. Notice something important. The value is obtained while the application is running. That's perfectly fine. But after assignment, it cannot change. For example, reassigning username is equal to Bob. This will give an error. Now let's look at const. Const p is equal to 3 when 14. This value is known before the application even starts. The compiler embeds it directly into the program. Another example, const second per minute is equal to 60. Perfect. But this const username is equal to fetch username fails because calling a function happens at runtime, not during compilation. Here is an easy way to remember. Ask yourself, can this value be known before the application starts? If yes, use const. Otherwise, use final. For example, const days in week is equal to 7. This is for compile time. Final current time is equal to datetime.now. This is for runtime. Simple. Sometimes we know a variable will definitely receive a value. just not immediately. For that, Dart provide the late keyword. For example, late string description, and later description is equal to load description. Finally, you can use print description. Everything works. But if we forget to initialize it and try to use print description, Dart throws an exception because late means I promise I'll initialize it before using it. You'll often see late inside classes. For example, class user late string name user string username and name is equal to username. The constructor initializes the variable. This pattern is extremely common in Flutter applications. Before ending today's lesson, here are some professional recommendations. Use var for local variables. Use explicit types for public APIs. Avoid dynamic whenever possible. Use final by default if a value won't change. And use cost whenever the value is known at the compile time. Use late only when initialization must happen later. Write meaningful variable names instead of var x. Prefer var user age. Good names makes code easier to read. Here are mistakes almost every beginner makes. Using dynamic everywhere. Using const with runtime values. Confusing var with dynamic. Using vague variable names. Forgetting to initialize late variables. Fortunately, you now know how to avoid all of them. Today we learned what variables are, how data static typing works, the difference between var and explicit types, the main built-in data types, the difference between var and dynamic, how final differs from cost, when to use the late keywords, and finally, the best practices professional Flutter developers follow every day. These concepts are foundations of every Flutter application you'll ever build. Master them now, and the rest of that will become much easier. Thank you so much for watching this first lesson. If you enjoyed it and learned something new, don't forget to like the video, subscribe to the channel, and turn on notifications so you don't miss the next lesson. In the next video, we'll build on everything we've learned today and explore operators and expressions in Dart. You'll learn how to perform calculations, compare values, combine conditions, assign value efficiently, and write expressions that power real-world applications. Until then, keep practicing, experiment with examples from this lesson, and remember, the best way to learn programming is by writing code. I'll see you in the next lesson. Happy coding!